Welcome back to Mr. Hassan's Maths channel. I'm now going to answer a question from a paper that I don't normally go through, which is the GCE paper from this is the A-level GCE paper, not the international A-level one. This is from the UK. This is the paper with code 9MAO, and this is paper 2. This is for the A-level course. This is a Pure Mathematics 2 paper from October 2021. Somebody had requested for me to answer this question, which is number 15, which is the last question on the paper. And I'm going to answer it because I've been asked to, but mainly because it also is a question which is relevant to what I'm teaching in the international A-level syllabus, and it's related to P3, which is about, this question is about trig identities and equations from P3. And so I'm going to go through this question because it's a kind of common type of question that comes up in our syllabus. Now, it says 15 part A, express 2 cosine theta minus sine theta in the form r cosine theta plus alpha, where r is greater than 0 and alpha is between 0 and pi over 2. Give the exact value of r and the value of alpha in radians to 3 decimal places. Okay, so now, when we want to solve a question like this, we want to express this in this form. Okay, now, the benefits behind expressing something like this in this form are two main benefits. One of them is if there's an equation involving something like this, you can solve it quite easily if you express it as a single trig ratio. Yeah? It's easy to solve rather than having two separate trig ratios like this, especially when none of them is squared. If it's like a squared, you can change them to each other easily. And also, if you want to find, for example, the maximum or minimum value of this expression, expressing in this form is easy for you to do that just by looking at the numbers here. So that's a couple of reasons why you would want to express this in this form. And we'll see how in part B and C that we're going to actually apply those or use those applications of expressing it in this form. Now, so part A says express this in the form. How do we do so? Well, what we do is we use what are called the addition formulae. Okay, and they are found in the formula book, although after a little bit of practice you should be quite used to them. And I have that copied from here. All right, that's copied from the formula book. This is one of them that will help us. This is the one that's related to what we have here, cosine of an angle plus another angle. So what you should first realize is the cosine of theta plus alpha will not expand to give you cosine of theta plus cosine of alpha, because this is not like a factor. This is like a whole thing as one kind of unit, cosine of this whole angle. This is an integral part of the cosine. You can't just have cosine on its own. It's not like x times theta plus alpha where you can expand and distribute the x in these two. No, this is a cosine of this whole angle. So if you want to expand something like that, you have to use the addition formula. The proof for this is there, but it's not really the time to go into it. So we're going to use this pattern here to expand this. So what I'm going to do first, I'm going to say, okay, I know that 2 cosine theta minus sine theta, I want to express it in the form r times cosine theta plus alpha. This is like an identity. I want it to be identical to this. So what I can say is, if I use this to expand, I have r times, and I'll have, if I use this pattern here, I'll have cosine theta times cosine alpha. Okay, now there's a plus here, there's going to be a minus there, minus, and you'll have sine of that first angle, which is theta, times sine alpha. Okay, and furthermore, what I can do, I'll just write this down so it becomes clear. Let me write this down properly. So this becomes 2 cosine theta minus sine theta is identical to r times cosine theta times cosine alpha minus r times sine theta times sine alpha. Now this identity we can use to try to find the value of alpha and r. And we can do that by what's called comparing the coefficients. So if I look at the coefficient of cosine theta on this side, and the coefficient of cosine theta on this side, they must have the same coefficient. They must have the same coefficient because this is identical to that. So the number of cosine thetas on this side must be the same as the number of cosine thetas on that side. On this side we have, so we're comparing cosine thetas. So if we compare the cosine theta, okay, on this side we have 2 cosine thetas. On that side we have r cosine alpha cosine theta. That's the coefficient of cosine theta on that side. So that's how we can, help to solve this problem. We can find what r and alpha is if we now also compare the sine thetas. So if I look at the sine thetas, let me just change the color. Here we have, well, there's 1 sine theta on this side, and here we have r sine alpha. Okay, now some people will say, what about the minus sign? Well, there's a minus here and a minus here, so it doesn't really matter. If you put -1 and minus r sine alpha, that minus will cancel anyway. So you got 1 sine alpha on this side. So comparing the sine theta, you have 1 sine theta on this side, and here we have r sine alpha times sine theta. So that's the coefficient of sine theta on that side. Now with these 2 equations, I can now find the value of r and alpha quite easily. Now there's 2 different ways to do it. I'll show you both ways because some people prefer one way than the other. There's not one way is better than the other, but the way I like to do it is I like to draw a little right angle triangle. And so there's my right angle. I call one of the angles alpha. I say, okay, I know from here, let me just do something else first, move that out of the way a little bit. I know from this equation, I can say that cosine of alpha is equal to 2 over r. And from this, I can say that the sine of alpha is equal to 1 over r. So the cosine of this angle alpha is 2 over r, so this would be the adjacent over the hypotenuse. And the sine of alpha is 1 over r, that will be the opposite, and that will be the hypotenuse. So from this right angle triangle, I can now work out the value of r. I can say r is equal to, by Pythagoras, the square root of 2 squared plus 1 squared, which is 4 plus 1, which is 5. So r is equal to the square root of 5. And I can also use the fact that the tangent of this angle is 1 over 2. So I can also say that from this triangle, that the tan of the angle alpha is equal to the opposite over the adjacent. So alpha is going to be inverse tan of a half. So I can work out what alpha is, and I have to give my answer in radians to 3 decimal places. Okay, so now I'm going to have inverse tan. Am I in radian mode? Yes, I'm in radian mode. We should know how to put this in radian mode. Okay, so we're going to have inverse tan of 1 over 2. Gives us 0.463, 0.46364. I'll just write it out to a few more decimal places. 0.4636647, 64 goes on. All right, so we want 3 decimal places, so we're going to stop there. So we can say alpha, therefore, is 0.464. Okay, that's in radians. So there's alpha, there's r. Okay, we have to write in the end. It says the question tells us to express this in this form. So I'm going to write it out in this form in the end. But I'll just show you the other method that we can use to solve this problem, which students use, and just so that those students who are used to that method can make that clear. So 2 equals r cosine alpha, 1 equals r sine alpha. This is found by comparing the coefficients. So that's up to that stage, it's the same. Now what you can do from here is I can call this equation 1 and equation 2. If I do equation 1 divided by equation 2, if I divide them, I end up with basically sine alpha over cosine alpha, the r's cancel, equals a half. So I end up with tan of alpha equals a half, and then the rest is the same, inverse tan of a half, and you get your answer 0.464 in the end. Okay, and the way to work out r using this other method is if you take equation 1 and you square it, you got 4 equals r squared times cosine squared alpha. You take equation 2 and you square it, you've got 1, because 1 squared is 1, r squared times sine squared alpha. And let me call that equation 3 and 4. And if I add these two equations together, 4 plus 1 is 5. And I have r squared times cosine squared alpha plus r squared times sine squared alpha. And then what we can do is we can take r squared as common. So we have r squared times cosine squared alpha plus sine squared alpha. And we know that sine squared of an angle plus cosine squared of the same angle is equal to 1. So I can replace that with a 1. So I end up with 5 equals r squared. So r equals the square root of 5. So we find the answers in a slightly different way. Okay, but both of those ways are acceptable. I personally, prefer this triangle method, but there's absolutely no problem whichever way you use. So now we can express this in that form. So 2 cosine theta minus sine theta. So we can say 2 cosine theta minus sine theta is equal to root 5 times cosine of theta plus 0.464, 3 decimal places. That's what they wanted us to express our answer like. And there's the answer to question number 1. Okay, so that's question number 15, part A. So that's 15 part A done. Now we're going to go on to part B. Okay, so part B. Let's have a look at part B. Now it says, here we have a figure 6 which shows the cross-section of a water wheel. Okay, the wheel is free to rotate about a fixed axis through the point C. The point P is at one end of the paddles of the wheel as shown in figure 6. The water level is assumed to be horizontal and of constant height. The vertical height, h meters of P above the water level, is modeled by this equation. 3 plus 4 cosine of 0.5 t minus 2 times minus 2 times the sine of the angle 0.5 t. So the same angle in both cases here, where t is the time in seconds after the wheel starts to rotate. Using the model, find the maximum height of P above the water level. All right, so now, what we just calculated in part A of the question, okay, is that we had the equation, it was 2 cosine theta minus sine theta equals root 5 times cosine of theta plus 0.464. Okay, that's what we just proved. Now, as I mentioned in the beginning of this question, I mentioned that expressing something like this in this form helps us to find maximum and minimum values of this expression. So it looks like that this is something that we have to deal with here. But what we have here and what we have here are not exactly the same, right? They're not exactly the same. However, we have to try to look at some sort of way of linking, especially this part here. Let me change that color. Especially this part here, okay, with this part here. How can I think of them as, or, how can I compare these to help me solve the problem? Now, first of all, I have 4 times cosine of an angle minus 2 times sine of the same angle. Here I have 2 times cosine of an angle minus sine of the same angle, okay? So I can see this is a 4 and this is a 2, this is a 2 and there's a 1 here, there's some sort of comparison. So if I take this expression and I take 2 out as a common factor from there, what I'll be left with inside the bracket will be of this type of form. So I can take what our h is, we can write it as 3 plus 2 times, and then I can put, that will be 2 cosine of the angle 0.5t minus sine of the angle 0.5t. Now, this now looks the same as that, and you can just say like the theta is the same as 0.5t. If you compare them, they're kind of like this, that's the angle. 2 times cosine of an angle minus sine of an angle. Now that means this part here, I can replace it with this, just put theta as 0.5t, that's all. So I can say h can be now expressed as 3 plus 2 times, then this can be replaced by root 5 times cosine of, instead of theta, I can put 0.5t plus 0.464. Okay, so that's now the same as, that's the same form as this. So this and that will be the same. I'll replace this with 0.5 times cosine of that angle plus 0.464. So I have now expressed h in a form which makes it easy for me to find its maximum and minimum value. Because we know that the cosine of any angle is always between 1 and -1. That's its maximum value and that's its minimum value. If you take the cosine curve, its highest it reaches is 1 and the lowest it reaches is -1. And it carries on that cycle. Okay, so if you think about just this section here, this part here, okay, this has a maximum of 1. So that means h max, maximum value of h, is going to be 3 plus 2 times root 5 multiplied by 1, which is, of course, 3 plus 2 root 5. And there's the answer for part 1. This is part 1 of this question, B part 1. Now, I think leaving like that would be fine. However, what I'm going to do here is I'll write it to 3SF as well, because that's normally what we're asked to do for non-exact answers. So I'll write that as 7.47. Okay, 7.47. So either of these two, and these are in meters, by the way. Okay, so either of these two would be correct, I think, if you express it in either way. All right, so there's B part 1. Now I'm going to go on to B part 2, but I think I will need this. So I'm going to take this, I think I'll need actually this part here. So I'll just take that across. Okay, now for part B part 2, it says, find the value of t when this maximum height first occurs, giving your answer to 1 decimal place. So we said the maximum height occurs when, basically, when this part, okay, is equal to 1. When that equals 1. So we can say that we've got, if we solve the equation, cosine of theta, well, not theta, remember we changed theta to 0.5t plus 0.464. Okay, theta, remember, is equal to 0.5t. All right, that's what we said. All right, so cosine of 0.5t plus 0.464, when that's equal to 1, that's when you're going to have h max. This is when you're going to have h max. So we're going to find the first time that this occurs. That's what we have to find here. All right, so that's what we're looking for. Now, we can solve this equation quite simply by just finding inverse cosine of 1. All right, if we find the inverse cosine of 1, our answer will be 0, and the answer will be, well, the calculator will give us 0 as our answer, because we know that cosine of an angle is 1 at 0 degrees, and then it goes like this, the cosine curve. The next time it equals 1 is at 2 pi in radians. All right, so of course we can't use 0 because that will give us a negative time. Okay, so we have to use as our answer 2 pi. So we have to use 2 pi. So we can say that t is going to be 2 pi minus 0.464 divided by 0.5. Okay, that will be the first time which this is going to reach its maximum height. So we can take this answer here. Okay, all right, we'll say 2 pi minus this answer. In fact, what I'll do is this. I'll have 2 pi minus answer over 0.5, and that gives us 11.639. That's 11.639 ... to 1 decimal place. So therefore, you can say the time is 11.6 seconds. 11.6 seconds is the time when it first reaches its maximum height. H is the maximum value. All right, that's part 2. Then it says, in a single revolution of the wheel, this is part C, P is below the water level for a total of t seconds. Okay, so we'll again use this. H equals 3 plus 2 times root 5 times the cosine of 0.5t plus 0.464. That's the way that we rewrote it. Okay, so in a single revolution of the wheel, P is below the water level for a total of t seconds. Okay, according to the model, find the value of t, giving your answer to three significant figures. So we got to find the time when this reaches the water level and the time when it reaches the water level again. Okay, so we need to find the times between it hitting the water level. Now, the water level, the value of h is 0. As I said, h is a height above the water level. So we want to find the times when h is below the water level. Okay, so if we find when it is actually at the water level and the difference between those two times, that will give us what we're looking for. So we have to solve the equation with this equals 0. And I said that's another application of expressing this in this form, that we can solve equations more easily. Solving this equation, it's written in this form, it's much easier for us because we only have one trig ratio. So if we say 3 plus 2 times root 5, because we're making h equals 0, cosine of 0.5t plus 0.464 is equal to 0. We can rearrange this to leave cosine of this angle, 0.464, is equal to, and we have negative 3 over 2 times root 5. So we can say 0.5t plus 0.464 is equal to, now we can use our calculator. It's already in radian mode, so there's no problem there. We say inverse of cosine of minus 3 over 2 times root 5. Okay, so that gives us the principal solution, which is 2.306. 2.306. Okay, I think we have to give our answers to three significant figures. So I mean, that's fine, but I'll just write to a couple of more places. 611. Okay, and we can round properly at the end. All right, now, always leave your things in a more accurate form is better, and then round at the end. So that's the principal solution. Okay, now we've got to find other solutions because there's more than one time then this is going to hit the water level. All right, there's going to be, we've got to find basically the shortest time because it's going to hit the water level at this time, then at this time, then again when it's gone around again. So, you know, if you find the first two times, I'm assuming that the first two times are when it hits it once and then it hits it again. Right, those are either if it's going that way or that way. But it could be the first time is when it hits it here, and the next time when it hits it there, and then the third time will be when it's below the water level. So we got to see which is the shorter time, I guess. Okay, the shorter time will be what we need to work out here. So this is the principal solution here. And as I was mentioning, there's other solutions which we have to find. And we have to find the time between those values. Okay, the time is going to be found when we rearrange this. All right, so that's one time. When I rearrange this, if I subtract 0.464 from this and divide by 0.5, that'll be one time when the paddle hits the water because that's when the height is 0. Another time will be when it goes up again. Another time would be when it goes all the way around and comes back down again. So I'm thinking the best thing for us to do here is to find 3 times, and the 2 times where the value between them is the shortest will be the time that we're looking for. All right, so that's what I'm going to do here. So I'm going to find the next time. Now, how do we find the other time using the cosine curve? Well, we know that the cosine curve looks like this. Okay, and we found one value over here because it was negative. Okay, that's what our calculator just gave you. That's the value, that's 2.3061 in radians. That's the value of the angle we just found. Now there's another angle over here which shares the same cosine ratio. Okay, and it's related to this angle because this distance is the same as that distance. So as we know with the cosine curve, to find the other main solution, we do 360 or 2 pi in this case minus the angle we found. So you're going to have 2 pi minus this angle, and that will give us the other solution. So if I take this angle that I found and I do 2 pi minus this angle, that will give me 3.97707. 3.9, what did I say? 97707. So that's the other time when it hits this paddle. Now it could be that I just found where it hits at this point and it goes all the way around to there, and then, you know, we need to find the next time then. or it could be that I found this time when it hits this place and then it hits that place, okay? Assuming it's going in that direction, it could be going the other direction, doesn't matter, but I could have found these 2 times, and that's what I'm looking for. But I just want to make sure by finding the next time it hits 0, and if that time is greater than between these 2, then I know that these 2 are correct. If it's shorter, then it's between the 2 that are shorter. Okay, because of course the time it takes to go from here to here is going to be less than the time it goes from there around to there. So that's what I'm just making sure of. So what I'm going to do is I'm going to think about the next time where it's going to have a solution to this equation, and that's going to be over here. Okay, which is 360 or 2 pi more than this. So for the cosine curve, once you found the 2 main solutions, to find other solutions, you add 2 pi to the answers. Okay, those 2 answers. I'm going to take this value here. I'm going to do 2 pi plus 2.30611. Or I should write it the other way around really, because I've got 2 point. It doesn't make any difference, but just to make it clearer. All right, plus 2 pi, and that will give me the next solution. And of course, that's going to be more than this distance. We can see that straight away. All right, because it's going to be much further. So of course, it's between these 2. I'm just making sure, that's all. So I can take the last answer and I can add 2 pi to it. That will give me 8.589. That's 8.589. Of course, we're looking between these 2. These 2 are the ones that's going to help us. So if I can find what these 2 times are, so I can say that the time 1 is going to be using this. So this is going to be 2.30611 minus 0.464 divided by 0.5, and time 2 is going to be 3.97707 minus 0.464 divided by 0.5. Okay, and then the difference between those times is what I'm going to be looking for. Okay, so now we can use the calculator to work out the 2 times. So we're going to have here 2.30611 minus 0.464. I could use a more accurate version, but it's okay, no problem. Divided by 0.5, and that gives us 3.68422. 3.68422, and then I can do the same thing here, but just change that to 3.97707, 3.97707, and that gives us 7.02614, 7.02614. So we know that the time that we're looking for is a difference between these 2, which is T2 minus T1. So I'm going to take this value and subtract from it. I'll just write it out, 3.68422. And that gives us the time, which is 3.34192. So 3.34192 seconds. And they want us to give the time to 3 significant figures. So that'll be 3.34, so the time is 3.34 seconds. So there's the answer for part C. Okay, so that's the answer for part C. Now there's a part D, I think. It says, in reality, the water level may not be of constant height. Okay, explain how the equation of the model should be refined to take this into account. Let me just have a quick look where this is. It doesn't tell us where the water wheel is. Okay, no problem. So basically, if the water level is not of consistent height. Now, this here is to do with the change of height of the paddle. So this is going to be something to do with the fixed height of the water. Okay, so basically, what we have to do is we have to think that this 3 will have to vary. Okay, so the 3 in the equation, the 3 will need to vary, okay, depending on what affects it. Now, there's only 1 mark, so we don't have to go into much detail, but for example, it might be, somewhere near the sea where the water level depends on the tide. You can have an equation that will, affect. You can model something for the change in height of the water level according to the tide or whatever, but the 1 mark here is just mention that the 3 will need to vary for us to refine this model, vary according to what affects it. We could say according, you don't really have to write this, but I'll just be a bit more precise. According to a model, okay, which affects its height. Okay, takes into account the factors which affect its height. Okay, so something like that, that's fine. All right, so there's the answer for part D, and that basically concludes this question number 15 from the October 2021 Pure Mathematics 2, paper 2, not the P2 from IAL, but the GCE from the UK paper. This is 9MA paper 2. This is from the A-level paper. Thank you for watching. Other questions that you might want to see from this paper, if I get around to answering them, will be in this playlist over here. The link will be over here. Other questions from this topic of basically trig identities and equations from P3. I'll put this under my P3 playlist, because this is what it relates to from what I do teach. You'll find it in the playlist for the rest of those type of questions in this section over here. You can subscribe to my channel by clicking on this link. Don't forget to look at the description of the video. You'll see some links that will take you to certain documents, indexes of the different types of material I've covered. You might find some of that useful. Thank you for watching, and see you soon.